In this video, we're going to look at some rational functions and how to integrate those, which will result in some arctan functions. So I've got two examples which we're going to look at. The first one is this one. So what I want to do is I want to take this rational function, which is a polynomial divided by a polynomial, and I want to split it up into as many partial fractions as possible. So to do that, what I'm going to do is I'm first of all going to try and factorize that denominator so I know how many pieces of the partial fractions we're going to have. So to do that, I'm just going to jump straight into equation mode on my GDC. And then I'm going to look at solving this polynomial. So I can find some roots. It's a third degree polynomial. Coefficients of 1, -3, 4, and -12. I can see there is one real one and two complex conjugates coming out. And for these questions in further mathematics, we would expect some complex roots, because if they were all real, then we can split this up into loads of linear denominators, which are A-level integrals as opposed to A-level further maths integrals. Okay, so x minus 3 then is a factor of the cubic of the denominator. So what I'm going to do is I'm going to factorize that denominator, and it's going to leave me with an x squared there. To get the minus 3, to get the minus 12, I need minus 3 times 4. And it turns out there's no linear term in this one. It could be 4x, which is what I have, and then minus 3x squared, which is what I have. And that's also evidenced by my other two roots, my complex conjugate roots of plus or minus 2i. And then the numerator is still the same. So that's 3x squared plus 5x plus 10. And for partial fractions, then, this is going to be identical to some constant divided by my linear factor, plus some linear bx plus c divided by my quadratic factor. Okay, in general, then the order of the one on top should be one less than the order of the one on the bottom. So because I have a quadratic on the bottom, I need a linear on the top. Okay, right, so that's my partial fraction setup. I'm going to times the whole thing by the denominator at the left to get rid of all my fractions, and that's going to give me 3x squared plus 5x plus 10 is identical to a into x squared plus 4 plus bx plus c times x minus 3. Okay, now from here there's kind of a couple of possible ways to proceed. Some of us would perhaps sub in some values, which is fine. We're looking for the values a, b, and c. What I'm going to do is I'm going to equate the coefficients. So I've got x squared, x, and then the constants. And for this to be an identity, those coefficients must align. So my coefficients of x squared, on the left-hand side, we have a 3. And on the right-hand side, we have an a plus a b. So that must be a plus b. My linear term, I've got a 5 on my left. There's no linear term here, but I have a c minus 3b there. And then my constant term, which I can write as x to the 0, I've got a 10 on my left. And then I've got 4a minus 3c. And what I've got here is I've got 3 equations in 3 unknowns. And what that's going to allow me to do is that's going to allow me to find the... That's right. Allow me to find the values of a, b, and c. So if I go onto my calculator, and now I go into, again, equation mode, but this time I'm going to go into simultaneous equations, and there's 3 unknowns. These are linear. Let's have my first column as a, so 1a. Second column is a b, so 1b. There's no c's in my first equation, and then that equals 3. No a's, minus 3b's, plus a c, and that's 5. And then in this one I've got 4 a's, no b's, minus 3 c's, and that equals 10. Solve that, and that gives me that a is 4, b is minus 1, and c is 2. Okay, right. How does that help us carry out the integral? Well, I've now split this single fraction up into 2 fractions, and then I can integrate both of those separately. So this integral now, which I'm going to call I, is going to be equal to the integral of a divided by x minus 3, which was 4, divided by x minus 3. And then I've got plus bx plus c, so plus minus 1, minus x plus 2, divided by x squared plus 4. And that is all integrated with respect to x. Okay. Right, now what I'm going to do is I'm going to have a go at making the differential of the denominator so that I can just state that it's going to be a log. And that's going to leave me with some kind of remainder. So let's just leave this fraction alone for a minute. And actually, I'll just put it in its own little integral over there. And then I'm going to have, well, the differential of x squared plus 4 is 2x. So if I have that as a 2x, then as a correction, I'm going to need to times this by negative a half out the front so that I do have my minus x. And that's going to be over x squared plus 4 dx. And then I've still got the plus 2. So I'm still going to have 2 times the integral of 1 over x squared plus 4 dx. So I've now split it up into 3 fractions. One was my linear factor from the bottom. This one, I forced the top to be differential to the bottom, ready for that to be a natural log. And then this one over here is that constant divided by the quadratic, which is going to give me an arctan. Okay. So now all those 3 are now ready to integrate. That is going to be 4 times the natural log of the mod of the bottom, which is x minus 3. This one I'm going to get minus a half times the natural log of the mod of the bottom, but the bottom is x squared plus 4, so I don't actually have to mod this one because it's always positive anyway. And then this one, well, that's going to be an arctan. A in this case is going to be 2 because it's the square root of 4. So that's going to be plus 2 divided by a, so actually there's no constant, arctan of x divided by a. And then all of my integral symbols have gone, so plus c. And that's the answer. Okay. We could combine these 2 logs together into one, but there's no need to. If you left your answer like that, then that would be absolutely fine. Okay, right, that's the first question. Let's have a go at another one. Similar kind of idea. All right, so we have a rational function. This time it's a linear divided by a quartic. And what I'm going to do is I'm going to start by factorising the bottom as best I can. So, leaving that mode going into polynomial solver, this is now a degree 4 polynomial. And the coefficient of x to the 4 is 1. Then it's minus 14, 73, minus 156, and 116. And that gives me 2 2's and then a pair of complex numbers. Okay, but the 2 2's being a repeated root means that x minus 2 squared is going to be a factor. So that must be a factor of that denominator. And if I multiply that out, that's x squared minus 4x plus 4. That must be a factor of the denominator. So I'm going to factorise this into a quadratic, which I can't factorise any further, times this quadratic, which is going to be those 2 linear terms. So I'm going to write x squared minus 4x plus 4. And to get the x to the 4 term, this first term must be x squared, because that's the only time an x to the 4 is going to come out. And then to get this 116, well, that must be a 29 at the end. So plus 29. Okay, that's the only way to get 116. All right, now to get this middle term, this linear term, 29 times minus 4, that's going to be negative 116. So negative 116 is the number of x's I've got currently, but I want negative 156, so I need to subtract another 40. I've got a plus 4 there, so to subtract the 40, that must be a minus 10x in there. Okay, so 29 times minus 4x is negative 116. Subtract the extra 40 I've just put in, gives me more minus 156. We should then definitely check that with the other terms. We've not looked at the cubic and quadratic. Okay, so the cubic term, it's going to be minus 4 minus 10 is minus 14, so that's fine. And then the quadratic term, well, for this one, I'm going to get 4. So the 4 times the x squared. I'm going to get the linear times the linear, which is plus 40. And then I'm going to get the quadratic times the constant, which is plus 29. So that's 73 x squared. Okay, so that's fine. That's factorised correctly. Okay, so now this fraction can be written as, I'm just going to call it f, can be written as something over x minus 2 plus something else over x minus 2 squared, because that factor has appeared twice. So that's how we deal with that from our partial fraction theory in A-level mathematics. Plus, now we have this quadratic, which can't be factorised any further with real numbers. So we're going to have to put a linear on top and divide that by the quadratic. Okay, now our job is to find our values of A, B, C, and D. Okay, now I'm going to do that in a similar way we just did the previous question. I'm going to multiply this whole thing by the denominator of the left, and f here is that fraction. So times by the denominator on the left, so that'll cancel all my fractions out, and I'll be left with a load of algebraic terms in x. So I'm going to get 11x minus 74, which is what's going to be left on the left-hand side. That's going to be identical to a into x minus 2 times this quadratic, x squared minus 10x plus 29, plus b times that quadratic, x squared minus 10x plus 29, and then I'm going to have this linear times the x minus 2 squared. So that's going to be plus cx plus d times x minus 2 squared. Okay. All right, so that's my identity. And again, there's a couple of different ways you can proceed from here. I'm going to equate the coefficients as I did before. So on the left-hand side, I should have some cubic terms. There's a cubic there, and there's going to be a cubic in there. No cubic here. So I need to look at x cubed, x squared, x to the 1, and x to the 0. So I'm going to get 4 equations, which is good because I've got 4 unknowns, A, B, C, and D. Okay, so my cubic on the left is 0, my quadratic on the left is 0, my linear on the left is 11, and my constant on the left is negative 74. So I can fill those out straight away. Okay, now it's going to get a little bit complicated, so just bear with me as we move through this. So the cubic term, as I said, there's one here and there's one over here. It's going to be the a x cubed, and I'm going to get a c x cubed, and those are the only places my cubic's going to come. So 0 is going to be a plus c. Quadratic term. Okay, so the quadratic term is going to come from the constant times the quadratic and the linear times the linear. Okay, so I'm going to get 2 quadratic terms from this first bit, and that's going to be minus 2, minus 10, that's minus 12 a's. And then over here, just the b. And then over here, the quadratic terms, I'm going to get d times the x squared. That's plus d. And then I'm going to get minus 2 x cx, and then another minus 2 x cx. So that's going to give me minus 4c. Okay, that's the quadratic term. The linear term is going to be the constant times the linear and the linear times the constant. So minus 10 times negative 2 is 20, and then plus 29 is 49. Linear term here, that's minus 10. Linear term here, if I take the cx on this bracket, then it's got to be the 2 constants here. So it's going to be 4c. And then here, the constant times the linear term, well, that was minus 4x here. So minus 4d. There. And then the constant term, this is going to start to get easy again now. So minus 2 times 29, that's minus 58 a's. 29 b's. no c's this time, and 4 d's. Here's my 4 linear equations in A, B, C, and D, and my calculator can cope with that. Because it's 4 unknowns, it can do up to 6, so that's fine. So if I if I go into equation mode, jump down to simultaneous equations and 4 unknowns. And again, what I'm going to do is I'm going to have column 1 as being my A values, column 2 as B's, C's as 3's, and D's as 4's. So the first equation, I've got 1A, no B's, I've got a C, and that's a 0 everywhere else. Second one, minus 12A plus a B minus 4C plus a D is also 0. Third line is 49A's minus 10B's plus 4C's minus 4D's, and that is 11. And then my last row, I've got minus 58A's, 29B's, no C's, 4D's, and that's going to equal negative 74. Okay, there we go. Nice integer numbers. We'd expect that in a question. The question would be engineered for that purpose. So because my first column was A, second was B, third was C, etc., these are in the order that I wanted. So that's A, B, C, and D. So minus 1, minus 4, 1, and minus 4. Okay. So that splits my fraction up into partial fractions. And now I can integrate each of those. So my integral then is going to be this fraction, which is now written as this thing. So I've got A, so it's minus 1 over x minus 2, minus 4 over x minus 2 squared. Okay, those are just A-level integrals, so that's nice and easy. Plus c, which is 1, so x, and then minus 4. All divided by x squared minus 10x plus 29. Okay, so that's split it up into partial fractions. And again, I'm just going to play that same game that I played with in the previous example. I'm going to make the top the differential of the bottom, and then I'm going to split this up into 2 fractions. So there's going to be minus 1 over x minus 2, minus 4 over x minus 2 squared. Don't need to do anything with those right now. They're ready to go now, so that's fine. I'm going to make the top the differential. So the differential at the bottom is 2x minus 5. So I need to times that by a half as a correction. So I've got just 1x. And then I've got x squared minus 10x plus 29. Okay. Oops, with a plus in there. And then my last term, because I've got some kind of left over here, what I've got here is I've got minus 5 halves kicking around, whereas actually I want minus 4, not minus 5 halves. So I need to correct that. And I correct that with... What did I do on my notes? Oh, the differential is a 10. What a muppet. There we go. Apologies, it's 2x minus 10, isn't it? Right, 2x minus 10 is the differential, so I need that. So I've got a minus 5, but I want a minus 4. So as a correction to that, I'm going to add 1 over x squared minus 10x plus 29. Apologies for that. Okay, so if I were to combine these 2 fractions back together again, I would get back to here. And I've done that, I've engineered that on purpose so that this fraction has the top as a differential at the bottom, and then this kind of picks up any slack that's left over. All of that is integrated with respect to x. Okay, right, now we've got these 3 fractions are ready to go, and now we need to tidy this one up. This one is going to be an arctan one, but before we go any further, we're going to need to complete the square in that. So that's going to be the integral of minus 1 over x minus 2, minus 4 over x minus 2 squared, plus a half into 2x minus 10, not 5, x squared minus 10x plus 29. And then I'm going to write this as x minus 5 squared plus 4, all under 1. And that is all integrated with respect to x. And now it's all ready to go. Okay. So this one, that is going to be the natural log of mod of x minus 2. And I need the mods on that one because that could be negative. This one here is a power. It's x minus 2 to the minus 2. So that's going to be plus 4 x minus 2 to the power minus 1. Okay, add 1 to the power, divide by new power. I can do that because the derivative of my substitution would be a constant, in this case the number 1, so that's all good. Plus a half times this integral, which is just the natural log of the bottom, because the differential, the top is the differential of the bottom. So that's going to be x squared minus 10x plus 29. Again, don't need mods on that one because the bottom is always positive. And then this one here, and this is an arctan one. A is 2 again, so I'm going to get a half arctan. This time is x minus 5 divided by 2. All of my integral symbols are now gone. So this is why I add my plus c, but I'm just going to pop it at the front. And I'm done. There we go, that's my answer. Okay. So that was probably a little bit harder than what you would expect to see in a further maths exam, but the principles are all required for what's needed in a further maths paper. So yeah, factorise the bottom as much as you can, put them into partial fractions, split the integral up into multiple fractions. This is quite a good technique. So I recommend spotting that, splitting up into 2 fractions, and then just go through each fraction to get the answer. So that's the technique for these ones. If you have any questions, please just drop them in the comments. But otherwise, I hope you found that useful. Thanks so much.